Okay, so if I am talking about slope, slope describes the steepness of a line. So if I compare these three different hills, this one is less steep than this one, and this one on the right is the most steep. So what we're going to do is we're going to find the different steepnesses of different slopes depending on if they're positive, negative, zero, all different kinds. First thing we're going to look at is from a graph. And from a graph, you're going to choose 2 points, and you're going to count the rise from one point to the next, and then the run. So in this case, here's my graph here. So I found 2 points that cross perfectly, and I'm going to count the rise. So here I would go 2 boxes up. So I like to write it as up 2. And then I'm here, so I need to get back to the line, so I need to go to the right one. And how you're going to write the slope is you're going to write the slope as a fraction, and it's always going to be your rise over your run. So in this case, I have a up 2, which would be a positive, and a right 2, which would also be a positive because up and right are both positives. So if I were to type that in my calculator, I would get that my slope is 2. I wanted to show you this. This one is not a point. It's a point on the graph, but it's not a good point to use to count the slope because it doesn't cross perfectly at the corner. And this is typically what some students will do. They'll mark any point on the line, but you want one that crosses like specifically at a corner and goes through, so that way you can easily count. Okay, let's do another one. So again, when I'm looking for points, this one crosses right at the center, at the origin. That one's not good, that one's not good, and this one crosses right here. So you want to just keep finding. So now I start from the bottom and I'm going up. So I rose 1. And this time I'm going 1, 2, 3 boxes to the left. So when I'm thinking about my signs, I have a positive 1 and I have a negative 3 this time because I went to the left. So if I were to use my calculator and I were to go to alpha y equals, and I would do 1 and negative 3, I get negative 1/3. So my slope here, my m, is negative 1/3. So that's how you find slope from a graph. The next is going to be from an equation. So the equation must be in slope-intercept form. And if you recall, that is y equals mx plus b. And out of all these, slope is the m of x. It's just the number. Most students will sometimes put the x, but it's just the number in front of the x. So if I'm looking at this and I rewrite y equals mx plus b, I can identify both my slope, my m, and my y-intercept. My m here, if I just kind of like circle it, right, it's right in front of the x, so it's 4/3. And my b, in this case, is a negative 12. That's my y-intercept. So for the next one, my m would be negative 3, and my b would be negative 2. For c, my m would be 15 because it's in front of the x, and my b this time is 7, positive, so I don't need to put the plus sign. And d is the only trick. My m is here, it's negative 0.1, but you'll notice there's nothing here. There's no plus anything. When there's nothing, it's like adding 0, which is why they don't write it. So my b is 0. So finding it from an equation that's in y equals mx plus b is pretty simple. Okay, the third way. The third way is finding it from a table. So what we're going to do is we need to find you need to figure out how much the x values are changing and the y values are changing. So typically we'll say the difference rate of change of the x values and the y values. And the way that you write it, we use this symbol. It's a triangle, it means delta. it stands for the change in y over the change in x. So what we're going to do is we're going to figure out how much it changes from each number. -1 sometimes is hard to start at, so I always start at a positive. So 0 to 1, how much is that changing? I would add 1. And I can check it again, 1 to 2, how much is that changing? I'd add 1 again. And then I would check the y's. So 2 to 4, I add 2. 4 to 6, I add 2. And if you think about it, 0 to 2, I also add 2. And -1 to 0, I also add 1. So now I just want to write it like the change in y over the change in x. So I'd have a +2 over a +1. And if I go to my alpha y equals and do 2 over 1, I'll just get a slope of 2. So sometimes tables are going to be horizontal. Most of the tables that we deal with, though, are vertical. But I would do the same thing. I find my change in my x's. 3 to 6 is adding 3. Ooh, but 6 to 12 is adding 6. And 12 to 15 is adding 3. Interesting. Let's try the other side. 20 to 16, I would take away 4. 16 to 8, I would take away 8. 8 to 4, I would take away 4. So this one's a little bit weird. Let's look at both situations. So one of them says -4 over +3. And if I were to type that in my calculator, -4, +3, oh, I would get the same thing. -4 over 3. But the other numbers are different, so let's see what they would give us. So what if I use the other one? -8 and +6. Let's see. Alpha y equals -8 and +6. I get the same thing. This is why using alpha y equals and reducing is important, because what you'll realize is they actually were the same thing no matter which ones you looked at. So sometimes tables will do that, and you want to make sure that it's consistent, or else it's not a linear equation. The last two we have is from a word problem and from 2 points. Now, from a word problem, there are some key terms that you can look for. Popular things to identify the slope are words like every, each, or per. And if you think about those words, if I say every minute, each minute, per minute, okay, those are rates of change. So when I'm reading this problem, I'm looking to identify the rate of change. So Jack has 5 toy trains, okay, 5. He plans to buy 2 new ones each month. So 2 new ones each month. There's that word each. So if I think about it, I can say, okay, well, 5 is what he's starting with, and he's buying 2 each month, which means the 2 is my slope, because that's what is happening every month. He's buying 2 more. B, the initial fee to have a website set up using a server is $48. So you notice they said initial fee is $48, and it costs $44 per month. So again, I'm looking for the rate of change. I'm looking for something that is each, every, per month is 44. My M here is 44. And the last one, C, an online camera store charges $149 for every 8x10 picture that you order. So $149 for every 8x10 picture. The shipping cost is $5.50. Well, how much are they charging for every picture? They're charging $1.49, which means that's my M. Okay, the last one is from 2 points, which you'll see is most commonly used in other math classes that you're going to see. So the first thing we want to do is we want to label our x and our y coordinates, and we want to find the change in y and the change in x using the formula. Here it is. It's m equals y2 minus y1 over x2 minus x1. The reason why we say label your x and y is so that way you don't get confused and you can do it all at once. When you get a point, remember you get an x and a y. And just to make it easier, I'm going to say this is my first x and this is my first y. And 4 is my second x and 17 is my second y. So when I use the formula, I'm going to write it here so you can see it all at once. I'm just going to substitute in those numbers. So my y2 is 17 minus my y1, which is 5, over my x2, which is 4, minus my x1, which is 0. And I'm just going to type in that entire thing into my calculator. So I have 17 minus 5 and 4 minus 0. And I'm going to use alpha y equals and type it all in at once. And I will get just 3. Okay, and let's do B. So let's label them again. This one's a little harder to label because of where they're located. X1, Y1, X2, Y2. So I have Y2 minus Y1 over X2 minus X1. And I'm going to start plugging things in. So my Y2 is negative 6 minus my y1 is negative 10. So sometimes you're going to have two negatives. My x2 is 0 minus my x1, which is negative 12. So this is where you're going to want to be careful and don't forget any negatives. Negative 6 minus negative 10 and 0 minus negative 12. And I'm going to get 1/3.